activity shown that travels along straight lines. How can we change the path of light? Do you know what happens when light falls on a polished or a shiny surface? Reflection of light. One way to change the direction of light is to let it fall on the shiny surface. For example, shining stainless steel plate or shining steel spoon can change the direction of light. The surface of water can also act like a mirror and change the path of light. Have you seen the reflect of trees or buildings on water? Any polished or shiny surface can act as a mirror. What happens even light falls on a mirror? You have learned physics that mirror change the direction of light that falls on it. This change of direction by a mirror is called a reflection of light. Reflection of light. Change of direction by a mirror. हेलो हाय अलविस ड्रीम बीपीसी टीचर। एटॉमिक स्ट्रक्चर मैम का समझ नहीं आ रहा है जो पढ़ा है। समझ में नहीं आया अच्छे से तो पढ़ाइए उसको एटॉमिक स्ट्रक्चर। उसको फिर से वीडियो देखिएगा एक दो बार तो समझ में आ जाएगा। ठीक है अच्छे से तो पढ़ाइए। थोड़ा लंबा टॉपिक है। तो एक काम कीजिएगा ना उसको फिर से वीडियो देखिएगा। अगर समझ में ना आए तो फिर तब यूट्यूब से ही कोई टीचर से आपको पढ़ना पड़ेगा या नहीं तो बुक से भी पढ़ सकते हैं। एक दो बार बुक भी रीडिंग कर सकते हैं। डाल्टन थॉमसन उसमें कन्फ्यूज़न होता होगा जैसे डाल्टन थॉमसन रदरफोर्ड का है ना क्या क्या कौन सा थ्योरी दिया है इसमें। तो उसके लिए आप जो है ना क्वेश्चंस हाँ वो होता है ना तो उसके लिए जो है ना क्वेश्चंस देखिएगा आप। जैसे जैसे नील बोर्स कौन थ्योरी दिया उसका क्वेश्चन या गूगल वगैरह में डालिएगा ना क्वेश्चंस चाहिए कौन कौन क्वेश्चन है। तो थ्योरी का तो उसमें आपको अलग अलग टाइप का क्वेश्चन देगा। रदरफोर्ड का क्या थ्योरी था और डाल्टन का कौन सा थ्योरी था तो उसका डिस्क्रिप्शन टाइप का क्वेश्चन रहता है तो उसको नोट कर लीजिएगा कहीं पे तो उसको पढ़िएगा तो समझ में आ जाएगा। क्योंकि ये सब इसका थ्योरी ऐसा ऐसा है ना तो एक बार पढ़ने में समझ में नहीं आता कंफ्यूज हो जाता है ये थ्योरी कौन दिया था थॉमसन दिया था कि नील बोर्ड दिया था कि कौन दिया था समझ में नहीं आता है। तो इसके लिए आपको जो उसका छोटा छोटा पॉइंट्स जो है नोट करना होगा। हाँ समझ में आ जाना चाहिए। समझ में आ जाना चाहिए। समझ में आ जाएगा उसमें देखिएगा जो जो पॉइंट्स रहेगा ना जैसे नील बोर्ड का कौन सा पॉइंट्स है उसको अलग करके लिख लीजिएगा उसको देखते रहिएगा ना तो हो जाएगा। कन्फ्यूज़न होता है हमको लगा कि ये सब कन्फ्यूज़न हमको भी हुआ था तो हम मेरा भी थोड़ा सा है अप डाउन तो हम भी उसी तरह किए थे जो अलग जो है नील बोर्स का जो जो बात वो कहा था अपना थ्योरी में उसको अलग उसको नोट किए हैं कहीं पे। तो उस तरह कीजिएगा ना तो हो जाएगा। मेरा कॉपी बहुत इतना साइंटिस्ट लोग हैं ना। कौन चैप्टर है उसमें? एटॉमिक स्ट्रक्चर 10th में है, 9th में स्ट्रक्चर ऑफ एटम 46 है ना, यही है थॉमसन मॉडल ऑफ एटम। इसका यहाँ जो है इसका ये दिया हुआ है, पॉइंट्स उसका दिया हुआ है यहाँ पे, तो देख सकते हैं। अच्छा, समझ में आ जाएगा। Vertically on the chart paper. Now direct the beam of light on the mirror from the torch with stilts. Right. Place the torch in such a way that its light is seen along the chart paper on the board. Now adjust its position so that the light from the torch strikes the plane mirror at the angle. Does the mirror change the direction of light that falls on it? Now move the torch slightly to other side. Do you find any change in the direction of reflected light? Look into the mirror along the direction of the reflected light. Do you see the slide in the mirror? This is the image of the slides. This activity is when the light gets reflected plane mirror. Let us play around the image format known as a little more about them. Handle the lighted candle with care. It's better the activity is performed in the presence of the teacher and the other person. Place a lighted candle in front of a plane mirror. Try to see the flame of the candle in the mirror. It appears as if a similar candle is placed behind the mirror. The candle which appears behind the mirror is the image of the candle formed by the mirror. The candle itself is the object. Now move the candle to different position in the front of the mirror. Observe in the change of the case. Was the image upright in each case? Did your flame appears on top of the candle as in object? Such an image is called erect. An image formed by a plane mirror is erect and the same size of the object. Now place a vertical screen behind the mirror. Try to obtain the object of the candle on the screen. On this screen, can you get this image on the screen? Now place the screen in front of the mirror. Can you get the image on the screen now? You will find that the image of the candle cannot be obtained on the screen in either case. What about the distance of the image from mirror? Let us perform another activity. What is square of the paper and fixed mirror vertically line is small object. You define that image is the same distance behind the mirror as the object is in front. Now verify this by the placing the object anywhere on the chart paper, right or left. When you see your image in a plane mirror, is it exactly like you have seen? You have noticed that there is one interesting differences between you and your image in a mirror. Let us find out. Stand in front of plane mirror, look at the standing rise left and found your image rise. It also here. Here is your hand, your image of the perfect kind of image. Right appears left, left appears right. That your side interchange in the other appears outside down. Now right and under the piece of paper hold the front of the plane mirror. How this appears in the mirror. Can you now understand why the word ambulance is written in it now? When the driver of a vehicle ahead of an ambulance look in, read ambulance written on it and give way to it. It is the duty of every one of us to allow an ambulance to pass without blocking its way. You might have observed that in the side mirror of the scooter or a car, the image of all the objects appear smaller than the objects themselves. Have you ever wondered why is it so? Hi Suleiman, playing with spherical mirrors. Pictures where the dinner was lift as stainless steel plates and saw this image on it. Oh, this plate acts as on a plane mirror. My image is erect and the and of it is of the same size. Erect and the same size. Bailey saw her image using the back of a steel spoon. Although look here, I can also see my erect image through it is smaller in size. This spoon also acts as a mirror or some kind of set by them. You can also use a spoon or any curved shiny surface to see your image. Spoon pulling outside the image. Now look at your image using the inner side of the spoon. This time you can find that your image is erect and larger in size. If you increase the distance of the spoon from your face, you may see your image inverted. You can also compare the image of your pen or pencil instead of your face. The curved shiny surface of a spoon acts as a mirror. The most common example of a curved mirror is a spherical mirror. Curved mirror is a spherical mirror. If the reflecting surface of a spherical mirror is concave, a spherical mirror is concave, it is called concave mirror. Reflecting surface is a convex mirror. Then the convex mirror. Why are concave and convex mirror called a spherical mirror? White rubber ball cut the portion of the knife of the saw blade. We carefully ask the elder person help in cutting the ball. Inner surface is a concave mirror. Outer surface is a convex mirror. The inner surface of a spoon acts like a concave mirror, while its outer surface acts like a convex mirror. We know that the image of an an object formed by a plane mirror cannot be obtained on a screen. Let us investigate if it is also true for the image formed by a concave mirror. You will conduct activity. Take a concave mirror, hold it facing the sun. Try to get the light reflected by the mirror on the sheet of the paper. Adjust the distance of the paper until you get a sharp bright spoon on it. Hold the mirror and the sheet of the paper steady for a few minutes. Does the paper start burning? This burning spot is in fact the image of the sun. Notice that this image is formed on the screen. An image formed on the screen is called a real image. Recollect that the activity the image format plane mirror could be not be obtained on the screen. Such an image is called a virtual image. Now let us try obtain on the screen image handle image on camera. Abstract the image of the candle falling at the mirror given the real image or virtual image size. Now move the candle towards the mirror and place at the different distance from it. In each case try to obtain the image on the screen. Record your observation table 5.1. It is possible to obtain the image on the screen when the candle is too close the mirror. We see We see that the image formed by a concave mirror can be smaller or larger in size the object. The image may also be real or virtual. Concave mirrors are used for many purposes. You might have seen doctors using concave mirrors for examining eyes, ears, nose, throat. Concave mirrors are also used by dentists. Dentists to see the enlarged image of the teeth. The enlarged image of the teeth. The reflectors of torches, headlights of the car and scooter are concave in shape. Would observe this image on the shiny surface of the bell on this new bicycle. Informed that this image was erect and smaller in size. Wondered if the ball is also kind of a spherical mirror. Can you recognize the type of the mirror? Now note that the reflecting surface on the bell is convex. Mirror, did you get image larger in size than the object? Can you see now? Recognize the mirror used as a side mirror in automobiles. These are convex mirror. Convex mirror can format object spread over a large area, so these help drive the scene effect behind them. Images formed by lenses. You might have seen a magnifying glass. It is used to read very small print. You might have also used it to observe by body parts of a cockroach or earthworm. The magnifying glass is actually a type of a lens. Lenses are widely used in spectacles, telescopes, and microscopes. Try to add a few more uses of lenses to this list. Get some lenses, touch and feel them. Can you find some difference just by touching those lenses which feel thicker in the middle than at the edges are convex lenses. Those which feel thinner in the middle than at the edge are concave lenses. Notice that the lenses are transparent and light can pass through them. Concave lens and convex lens. Let's play them. It is dangerous to look through a lenses at a sun or bright lights. You should also be carefully not to focus sunlight with the convex lens on any part of your body. A convex lens, a concave lens. Take a take a convex lens, a magnifying glass, put the path of sun rays, place a sheet of the paper so adjust distance between lens and the paper till and bright spot on the paper. Hold the lens and the paper of the position of the millimeter does the paper of viewers. Now replace the convex lens with a concave lens. Reduce bright spot. Bright sometimes. We seen in the case of mirrors with the different position of the object, nature of the size of the image, the lenses of object. Take convex flexible stand as also did with the concave mirror. Advantage light and candle of the distance of about 5 cm from the lens. Try to obtain the image of the candle of on the paper screen placed on the other side of the lens. You may have to move the screen towards or may on the lens to get sharp image of the flame. What kind of image did you get? It is real or virtual? Now vary a distance of the candle. Now lens try to obtain the image of the candle flame every time on the paper screen by moving it. Further your observation activity 5.7 mirror. Did you get in any position of an object image which was erect and magnified? Could this image be obtained on the screen? Is the image real or virtual? This is how a convex lens is used as a magnifying glass. In a similar fashion, study the image formed by a concave lens. You will find that the image formed by a concave lens is always virtual, erect and smaller in size than the object. Sunlight, white or colored. Have you ever seen a rainbow in the sky? You might have noticed that it appears usually after the rain. Then the sun is low in the sky. The rainbow is screen as a large arc in the sky with many colors. How many colors are present in the rainbow? When observed carefully, there are 7 colors in the rainbow. Through it may not be easy to distinguish all of them. These are red, orange, yellow, green, blue, indigo, violet. You might have seen that the you blows of bubbles. They appear colorful. Similarly, when the light is reflected from the surface of the compact disc changing many colors. On the basis of this experience, could we say that the sunlight is the mixture of different colors? Let us investigate. Take the allow narrow beam sunlight through the small holes of the window, dark the one of the face of the prism. Let us coming of the prism is split beam of light in 7 colors. A white sheet of the paper or a white wall. What do you observe? Do you see colors similar to those of the rainbow? This shows that the sunlight consists of 7 colors. The sunlight is said to be white light. This means that the white light consists of 7 colors. Try to identify these colors and write their name of your notebook. Can you please submit release complete parameter? 7 segments paints the 7 rainbow colors on these segments. So figure it now. You can also paste colored paper on these segments. Make a small hole in the center of the disc. Fix the disc loosely on the tip of the refill of a ball pen. Ensure that the disc rotates freely. Rotate the disc daylight when the disc rotates fast. The color mixed together of the disc appears when the white is which such is popularly known as Newton's disc. Disc with 7 colors appears white on रोटेशन करेंगे तो उसको वाइट दिखाई देगा, उसको न्यूटन डिस्क कहता है। लाइट ट्रेवल्स अलोंग स्ट्रेट लाइन, लाइट जो है स्ट्रेट लाइन में ट्रेवल करता है। एनी पॉलिश और ए शाइनी सरफेस एक्ट्स और ए मिरर, an image which can be obtained on the screen is called a real image. An image which cannot be obtained on a screen is called a virtual image. Cannot be obtained on a screen is a virtual image. The image formed by a plane mirror is erect. It is virtual and is the same size of the object. The image is at the same distance behind the mirror as the object is the front of it. In an image formed by a mirror, the left side of the object is seen on the right side of the image, and the right side of the object appears to be on the left side of the image. Concave mirror can form a real and inverted image. When the object is placed very close to the mirror, the image formed is virtual, erect and magnified. Image formed by a convex mirror is erect, virtual and smaller in size than the object. A convex lens can form real and inverted image. When the object is placed very close to the lens, the image format is virtual, erect and magnified. Then when used to object magnified, a convex lens is called a magnifying glass. A convex lens always forms erect, virtual and similar image of the object. White light is composed of 7 colors. White light is composed of 7 colors. Blows of bubbles. Color 7 colors of frozen water: red, orange, color blue, white, violet. Newton's disc, whitish disc, जब उसको we do not magnifying glass, convex lens used magnifying glass, virtual study of the image of the real image, virtual image. Curved spherical mirror because spherical mirror is a concave mirror, convex lens mirror, convex mirror of the object. बस इतना और है नहीं इसमें इम्पोर्टेंट कुछ। पिन होल कैमरा ऑब्जेक्ट स्ट्रेट लाइन, पिन होल कैमरा ऑब्जेक्ट स्ट्रेट लाइन में चलता है, ऑब्जेक्ट उल्टा दिखता है। शेडो शेप साइज डिफरेंट, ओपेक सोर्स स्क्रीन, ट्रेवल स्ट्रेट लाइन, रिफ्लेक्ट मिरर।